In one of the driest places on Earth, a NASA robot is searching for water. The Mojave Desert in Southern California receives very little rain, and the dry environment is very similar to the surfaces of the Moon and Mars. However, there is enough underground moisture that the Mojave is an excellent lunar or red planet analog. Also, since the locations and quantities of that moisture are well known to geologists, researchers are able to ground truth science instruments by comparing their measurements to the actual amounts. The Mojave Volatiles Prospector, or MVP project, is a testbed for scientists from NASA Ames Research Center to develop the technologies and procedures that will be needed to search for water ice and other volatiles that might be hidden under the surface of the Moon, Mars, or another planetary body. The foundation of the MVP project is a four-wheel drive electric-powered robot known as KREX. About the size of a golf cart, KREX is designed to autonomously navigate rugged terrain while driving over obstacles as high as 12 inches and slopes as steep as 30 degrees. It has multiple cameras on board, which are used by the rover's control system to navigate between waypoints and to provide real-time situational awareness for the science team back at NASA Ames. To search for water, KREX carried two instruments specifically selected for the MVP mission. The first was a Neutron spectrometer system known as NSS that scans for underground hydrogen. NSS measures changes in the energy of neutrons that interact with hydrogen in the subsurface. If there is no hydrogen, those changes are not detected. The second instrument was the near-infrared volatile spectrometer system known as NIRVSS. NIRVSS measures light reflections from soil samples and was used to help calculate the amount of soil moisture. Data from the two instruments helped scientists select locations where samples were collected for analysis. For science planning and mission operations, the team used a software tool developed at Ames called the Exploration Ground Data System, or XGDS. The MVP deployment was an opportunity to learn how the web-based software tool works and where improvements are needed in order to conduct a high-tempo science mission with a rover in a remote location. Another goal of the MVP project was to answer the question, how can NASA use a robot to prospect for resources on the Moon in a very short time frame? The Mojave Volatiles Prospector mission brought together a rugged robotic rover, unique prospecting instruments, a robust mission operations software package, and a dedicated support team for a remote live field test. The mission successfully demonstrated the concept of high-tempo robotic science, and the MVP team stands ready to help develop an actual prospecting mission beyond planet Earth.